Algebra is one of the broad parts of mathematics, together with number theory, geometry and analysis. In its most general form, algebra is the study of mathematical symbols and the rules for manipulating these symbols. It is a unifying thread of almost all of mathematics. As such, it includes everything from elementary equation solving to the study of abstractions such as groups, rings, and fields. The more basic parts of algebra are called elementary algebra. The more abstract parts are called abstract algebra or modern algebra. Elementary algebra is generally considered to be essential for any study of mathematics, science, or engineering, as well as such applications as medicine and economics. Abstract algebra is a major area in advanced mathematics, studied primarily by professional mathematicians. Much early work in algebra, as the Arabic origin of its name suggests, was done in the Near East by mathematicians such as Al-Khwarizmi and Omar Khayyam. Elementary algebra differs from arithmetic in the use of abstractions, such as using letters to stand for numbers that are either unknown or allowed to take on many values. For example, in the letter is unknown, but the law of inverses can be used to discover its value. In the letters are no variables, and the letter is a constant. Algebra gives methods for solving equations and expressing formulas that are much easier than the older method of writing everything out in words. The word algebra is also used in certain specialized ways. A special kind of mathematical object in abstract algebra is called an algebra, and the word is used, for example, in the phrases linear algebra and algebraic topology. A mathematician who does research in algebra is called an algebraist. Etymology. The word algebra comes from the Arabic from the title of the book Ilm al-Jabr al-Muqabbala by Al-Khwarizmi. The word entered the English language during the 15th century, from either Spanish, Italian, or medieval Latin. It originally referred to the surgical procedure of setting broken or dislocated bones. The mathematical meaning was first recorded in the 16th century. Different meanings of algebra. The word algebra has several related meanings in mathematics, as a single word or with qualifiers. As a single word without article, algebra names a broad part of mathematics. As a single word with article or in plural, algebra denotes a specific mathematical structure, whose precise definition depends on the author. Usually the structure has an addition, multiplication, and a scalar multiplication. When some authors use the term algebra, they make a subset of the following additional assumptions: associative, commutative, unital, and or finite-dimensional. In universal algebra, the word algebra refers to a generalization of the above concept, which allows for NARY operations. With a qualifier, there is the same distinction. Without article, it means a part of algebra, such as linear algebra, elementary algebra, or abstract algebra. With an article, it means an instance of some abstract structure, like a Lie algebra, associative algebra, or vertex operator algebra. Sometimes both meanings exist for the same qualifier, as in the sentence. Commutative algebra is the study of commutative rings, which are commutative algebras over the integers. Algebra is a branch of mathematics. Algebra began with computations similar to those of arithmetic, with letters standing for numbers. This allowed proofs of properties that are true no matter which numbers are involved. For example, in the quadratic equation can be any numbers whatsoever, and the quadratic formula can be used to quickly and easily find the value of the unknown quantity. As it developed, algebra was extended to other non-numerical objects, such as vectors, matrices, and polynomials. Then the structural properties of these non-numerical objects were abstracted to define algebraic structures such as groups, rings, and fields. Before the 16th century, mathematics was divided into only two subfields, arithmetic and geometry. Even though some methods, which had been developed much earlier, may be considered nowadays as algebra, the emergence of algebra and soon thereafter, of infinitesimal calculus as subfields of mathematics only dates from the 16th or 17th century. From the second half of 19th century on, many new fields of mathematics appeared, most of which made use of both arithmetic and geometry, and almost all of which used algebra. Today, algebra has grown until it includes many branches of mathematics, as can be seen in the mathematics subject classification, where none of the first-level areas is called algebra. Today algebra includes section 08 general algebraic systems, 12 field theory and polynomials, 13 commutative algebra, 15 linear and multilinear algebra, matrix theory, 16 associative rings and algebras, 17 non-associative rings and algebras, 18 category theory, homological algebra, 19 K-theory and 20 group theory. Algebra is also used extensively in 11 number theory and 14 algebraic geometry. History. The start of algebra as an area of mathematics in Europe may be dated to the end of 16th century, with François Witt's work. Until the 19th century, algebra consisted essentially of the theory of equations. In the following, prehistory of algebra is about the results of the theory of equations that precede the emergence of algebra as an area of mathematics. Early history of algebra. The roots of algebra can be traced to the ancient Babylonians, who developed an advanced arithmetical system with which they were able to do calculations in an algorithmic fashion. The Babylonians developed formulas to calculate solutions for problems typically solved today by using linear equations, quadratic equations, and indeterminate linear equations. By contrast, most Egyptians of this era, as well as Greek and Chinese mathematics in the first millennium BC, usually solved such equations by geometric methods, such as those described in the Rhind mathematical papyrus, Euclid's Elements, and the 9 chapters on the mathematical art. The geometric work of the Greeks, typified in the Elements, provided the framework for generalizing formulae beyond the solution of particular problems into more general systems of stating and solving equations. Although this would not be realized until mathematics developed in medieval Islam. By the time of Plato, Greek mathematics had undergone a drastic change. The Greeks created a geometric algebra where terms were represented by sides of geometric objects, usually lines, that had letters associated with them. Diophantus was an Alexandrian Greek mathematician and the author of a series of books called Arithmetica. These texts deal with solving algebraic equations, and have led, in number theory, to the modern notion of Diophantine equation. Earlier traditions discussed above had a direct influence on Muhammad ibn Musa al-Khwarizmi. He later wrote the compendious book on calculation by completion and balancing, which established algebra as a mathematical discipline that is independent of geometry and arithmetic. The Hellenistic mathematicians Hero of Alexandria and Diophantus, as well as Indian mathematicians such as Brahmagupta, continued the traditions of Egypt and Babylon. Though Diophantus' Arithmetica and Brahmagupta's Brahmasphata are on a higher level. For example, the first complete arithmetic solution to quadratic equations was described by Brahmagupta in his book Brahmasphata. Later, Persian and Arabic mathematicians developed algebraic methods to a much higher degree of sophistication. Although Diophantus and the Babylonians used mostly special ad hoc methods to solve equations, Al-Khwarizmi contribution was fundamental. He solved linear and quadratic equations without algebraic symbolism, negative numbers or zero. Thus he has to distinguish several types of equations. In the context where algebra is identified with the theory of equations, the Greek mathematician Diophantus has traditionally been known as the father of algebra, but in more recent times there is much debate over whether Al-Khwarizmi, who founded the discipline of algebra, deserves that title instead. Those who support Diophantus point to the fact that the algebra found in Algebra is slightly more elementary than the algebra found in Arithmetica, and that Arithmetica is syncopated while Algebra is fully rhetorical. Those who support Al-Khwarizmi point to the fact that he introduced the methods of reduction and balancing, which the term Algebra originally referred to, and that he gave an exhaustive explanation of solving quadratic equations, supported by geometric proofs, while treating algebra as an independent discipline in its own right. His algebra was also no longer concerned with a series of problems to be resolved, but an exposition which starts with primitive terms in which the combinations must give all possible prototypes for equations, which henceforward explicitly constitute the true object of study. He also studied an equation for its own sake in a generic manner, insofar as it does not simply emerge in the course of solving a problem, but is specifically called on to define an infinite class of problems. Another Persian mathematician, Omar Khayyam, is credited with identifying the foundations of algebraic geometry and found the general geometric solution of the cubic equation. Yet another Persian mathematician, Sharaf al-Din al-Tusi, found algebraic and numerical solutions to various cases of cubic equations. He also developed the concept of a function. The Indian mathematicians Mahavira and Bhaskara II, the Persian mathematician Al-Khariji, and the Chinese mathematician Zhu Shijia solved various cases of cubic, quartic, quintic and higher-order polynomial equations using numerical methods. In the 13th century, the solution of a cubic equation by Fibonacci is representative of the beginning of a revival in European algebra. As the Islamic world was declining, the European world was ascending, and it is here that algebra was further developed. History of Algebra. François Vièt's work on new algebra at the close of the 16th century was an important step towards modern algebra. In 1637, René Descartes published La Géométrie, inventing analytic geometry and introducing modern algebraic notation. Another key event in the further development of algebra was the general algebraic solution of the cubic and quartic equations, developed in the mid-16th century. The idea of a determinant was developed by Japanese mathematician Kawasaki in the 17th century, followed independently by Gottfried Leibniz 10 years later, for the purpose of solving systems of simultaneous linear equations using matrices. Gabriel Kramer also did some work on matrices and determinants in the 18th century. Permutations were studied by Joseph Louis Lagrange in his 1770 paper Réflexions sur la résolution algébrique des équations, devoted to solutions of algebraic equations, in which he introduced Lagrange resolvents. Paolo Ruffini was the first person to develop the theory of permutation groups, and like his predecessors, also in the context of solving algebraic equations. Abstract algebra was developed in the 19th century, deriving from the interest in solving equations, initially focusing on what is now called Galois theory, and on constructibility issues. George Peacock was the founder of axiomatic thinking in arithmetic and algebra. Augustus de Morgan discovered relation algebra in his syllabus of a proposed system of logic. Josiah Willard Gibbs developed an algebra of vectors in three-dimensional space, and Arthur Cayley developed an algebra of matrices, areas of mathematics with the word algebra in their name. Some areas of mathematics that fall under the classification abstract algebra have the word algebra in their name. Linear algebra is one example. Others do not. Group theory, ring theory, and fields theory are examples. In this section, we list some areas of mathematics with the word algebra in the name. Elementary algebra, the part of algebra that is usually taught in elementary courses of mathematics. Abstract algebra, in which algebraic structures such as groups, rings and fields are axiomatically defined and investigated. Linear algebra, in which the specific properties of linear equations, vector spaces and matrices are studied. Commutative algebra, the study of commutative rings. Computer algebra, the implementation of algebraic methods as algorithms and computer programs. Homological algebra, the study of algebraic structures that are fundamental to study topological spaces. Universal algebra, in which properties common to all algebraic structures are studied. Algebraic number theory, in which the properties of numbers are studied from an algebraic point of view. Algebraic geometry, a branch of geometry, in its primitive form specifying curves and surfaces as solutions of polynomial equations. Algebraic combinatorics, in which algebraic methods are used to study combinatorial questions. Many mathematical structures are called algebras. Algebra over a field, or more generally algebra over a ring. Many classes of algebras over a field or over a ring have a specific name. Associative algebra, non-associative algebra, Lie algebra, Hopf algebra, C** algebra, symmetric algebra, exterior algebra, tensor algebra. In measure theory, sigma algebra, algebra over a set. In category theory, F algebra and F algebra, T algebra. In logic, relational algebra, a set of finitary relations that is closed under certain operators. Boolean algebra, a structure abstracting the computation with the truth values false and true. The structures also have the same name. Hating algebra. Elementary algebra. Elementary algebra is the most basic form of algebra. It is taught to students who are presumed to have no knowledge of mathematics beyond the basic principles of arithmetic. In arithmetic, only numbers and their arithmetical operations occur. In algebra, numbers are often represented by symbols called variables. This is useful because it allows the general formulation of arithmetical laws, and thus is the first step to a systematic exploration of the properties of the real number system. It allows the reference to unknown numbers, the formulation of equations and the study of how to solve these. It allows the formulation of functional relationships equals 3x minus 10, where f is the function, and x is the number to which the function is applied. Polynomials. A polynomial is an expression that is the sum of a finite number of non-zero terms, each term consisting of the product of a constant and a finite number of variables raised to whole number powers. For example, x2 plus 2x minus 3 is a polynomial in the single variable x. A polynomial expression is an expression that may be rewritten as a polynomial by using commutativity, associativity and distributivity of addition and multiplication. For example, is a polynomial expression that, properly speaking, is not a polynomial. A polynomial function is a function that is defined by a polynomial, or, equivalently, by a polynomial expression. The two preceding examples define the same polynomial function. Two important and related problems in algebra are the factorization of polynomials, that is, expressing a given polynomial as a product of other polynomials that cannot be factored any further, and the computation of polynomial greatest common divisors. The example polynomial above can be factored as. A related class of problems is finding algebraic expressions for the roots of a polynomial in a single variable. Education. It has been suggested that elementary algebra should be taught to students as young as 11 years old, though in recent years it is more common for public lessons to begin at the 8th grade level in the United States. Since 1997, Virginia Tech and some other universities have begun using a personalized model of teaching algebra that combines instant feedback from specialized computer software with one-on-one and small group tutoring, which has reduced costs and increased student achievement.